In this video, I want to go over solving equations with variables on both sides. You can see in this first example, we have 7x minus 3, and then we also have a 3x plus 17. So we have a variable, x, on both sides of the equation. And that's okay. All we have to do is combine like terms here. So I'm going to first add 3 to both sides. That'll give us 7x is equal to 3x, and 17 plus 3 is 20. Next step, I'm going to subtract 3x from both sides. 7x minus 3x is 4x, and that is equal to 20. And now it's just a one-step equation. Divide by 4 on both sides. X is equal to 5. Okay, the next example. Using grouping symbols. Okay, so you know that this 3 has to be multiplied. It's called the distributive property, to both the 4x and the 2x. And this 5, since everything here is in parentheses, we have to multiply it to the x and the 3. So that's the only difference. Once we do this one step, it'll turn back to looking like this first problem. Okay? So let's distribute. All right. So we have 3 times 4x, is 12x. 3 times negative 2 is negative 6. Okay, we're done with that left side. All we had to do was distribute the 3, meaning multiply it by both of these terms. All right, on the other side, we have to distribute the 5. Okay, so 5 times x is 5x. And 5 times 3 is 15. Okay, now this problem looks similar. You can do this. First, let's add 6 to both sides. So we have 12x is equal to 5x plus 21. Now, I'll subtract 5x from both sides. This is 7x is equal to 21. And now it's a one-step equation. Divide by 7, divide by 7. And I'll put it over here. X is equal to 3. One more example that's actually 2 more, sorry. So these are kind of odd cases here. They're not odd, but they're cases that you're going to run into and you might not know how to tackle them. If you get a case, so first of all, this first example on the left here is infinitely many solutions. So when we look at this, when we just start to solve this, we're going to realize something odd is going on, and also realize that that indicates that there's going to be an infinite number of solutions. I can plug in, all the real numbers into this, in for x, and it'll make the equation true. Let's see what happens. Okay, so it looks like I have variables on both sides, and it looks like I have a distributive grouping issue here on the right. So that's what I'm going to take care of first. I'm going to do 21x plus 6 is equal to, and then I'm going to distribute this 3 to the 7x and this 3 to the 2. That is 21x, and then 3 times 2 is 6. Okay, now what you see here, you see 21x plus 6 is equal to itself, 21x plus 6. So I can put in any number, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1.5, 1.2, pi, whatever. And this side is always going to equal this side because they're identical. Okay? They're identical. So we would say, if you run into this situation, you'd say that there's infinitely many solutions. All right, on to the next problem. This problem is going to have no solution. Okay, this is our no solution example, and let's see what it turns into when we start playing around here. Okay, so I can combine like terms. I don't have any distributive issues, so I'm just going to combine this 8x and this negative 3x on the first side here. Okay, so that's going to be a 5x minus 4 is equal to 5x plus 1. Okay, so when you come across a scenario like this, where you have 5x minus 4 is equal to 5x plus 1, there's never going to be anything that can satisfy this. So this is going to have no solution. If you did not happen to see that right away and you kept on going through and tried to solve for x, let's see what would happen. Plus 4 plus 4. So that's going to be a 5x is equal to 5x plus 5. I'll subtract a 5x from both sides, and I'll get 0 is equal to 5. Uh-oh. There's an issue here. 0 does not equal 5. So that is an indication that there's no solution. If you didn't realize with the left problem, with the infinitely many solution problems, that you had a scenario that had infinitely many solutions and you tried to solve for x, let's see what would happen. Negative 6, negative 6. Okay, so I have 21x is equal to 21x. I think you'd realize by now, but if you didn't, divided by 21, divided by 21, you just have x is equal to x. Okay? So you get some kind of true statement here, and you get some kind of false statement here when you are trying to solve.